Welcome back to Insight Builder channel, big data learners, data leaders, and my dear friends. How to perform your first ETL, that is extract, transform, load on Spark cluster. Step-by-step guide with planning on Jupyter notebooks. What we need? We need to first of all read the data from a CSV file. We need to modify the column names. We need to create a new table under the name customer Spark table, and we have to create a new database also. We need to execute a simple filter transformation where we want to select the rows that are having income that is above 15,000 and a spending power of above 50. And we need to write a new table inside the Spark metastore and also write the table, the filter transform table, into a CSV file and then come out of the process. This is what we are going to do. So this is what is required at the outset. So you don't know what is the data set, you don't know anything about that. Don't worry about it. This is what we need. Okay. How are we going to do it? So we are going to use Kaggle notebook to explore some data. We are going to check all the execution and perfect it. Then write a Python script that can be submitted to Spark as a job, and then we execute it in the cluster. Simple 4 steps. We are going to go to Kaggle. This particular link already has the various activities that we spoke about here to explore the data, to do the execution perfection. It is already available there. We will be showing it in a moment. And what we are going to do is, after that we are going to move to the cluster, and we have to actually do certain things before we do this particular step. Okay. Instead of using the Pyspark, we cannot actually use Pyspark as a execution method, like how you execute Python scripts, like using Python and then giving the script name. That's not how we can execute the Spark jobs. We have to do it in a different way, and this is how we do it. In order to do that, we need to actually have these master started and also the workers assigned to that master, and then we can actually assign the application to the master, and master can execute it. All these things we will be seeing in this video. Without further ado, let us go to the Kaggle notebook. Before that, ensure that this particular setup is given for you guys to practice. Try to practice with the Kaggle notebook as well as with your own cluster. If you are new to cluster, if you are actually unaware of how to get your own cluster, then take a look at my playlist. You will find a lot of options of how to build your own cluster, whether you are going to do it using EMR in AWS or you want to build it from the scratch. I'll be using the cluster that I built from the scratch. Okay, so it's fairly simple. Once you do it once or twice, then it becomes very simple. Actually, it's like installing Linux in your operating system, in your laptop. And I hope that you like this content, and do leave a like for this video and subscribe to my channel so that you can get more updates on the big data and as well as various other topics. Now let us move to the browser. In the browser, I have already started the instance where I will be running the execution. So the instance has been already started. The Kaggle notebook that we will be working on will be also, the link will be shared with you guys in the YouTube description. So don't worry about that, it is already shared. You don't need to worry about the data also. The Kaggle notebook already has the data inbuilt into that, and the necessary transformation is also already simulated before we going to use it for submitting into Spark cluster. Now the Kaggle notebook is coming, so in the meantime I would like to also explain certain things inside the instance that we need to do in order for us to work effectively with the Spark cluster. Because we are going to do a Spark submit, you need to give additional ports opening in this particular instance. So for that, what you have to do is, you have to go to security. Inside the security groups, ensure that you open up 8080 port as well as the port number 22. So you should be able to SSH, and also you should be able to do HTTPS. So that is also required. And yeah, the custom TCP for 8080 also should be opened up. It is required, and also open up 7077 also. Why I am actually asking this, these are the ports through which the Spark master talks with the web interface. So that's why I'm asking you to open it. The SQL, the Kaggle notebook is up and running. The Kaggle notebook actually uses the Pyspark library to work with the dataset. We are going to execute Spark commands inside the Kaggle notebook, and the same commands we will be executing, but in a little bit different way once we write it as a script. So that is more important. You cannot actually execute the Jupyter notebook in live environment, or you cannot use it for production. For production, you need to write the code in a different way. Okay, because the purpose of the Kaggle environment or the Jupyter notebook is for you to explore, for you to test your ideas, for you to understand more about what kinds of options you can use for transforming the data. When it comes to production, it's all fixed. You cannot keep on changing. So the script is fixed, right? You will be running it multiple times. So so keep that in mind as we go through this notebook, and then we will start working on. The important point is that the idea of using ETL, doing ETL inside the cluster is not same as doing ETL inside the Pyspark environment. So keep that in mind alone. So let the Pyspark get installed. The draft session is getting started right now. So the session has got started and the installation has begun. Let me get back to you once it is. In the meantime, I can also show you the other videos that you can refer to. In the YouTube channel, you can take a look at this two series of videos where I talk about building your own big data cluster from the scratch, and the ideas are pretty stable ideas that we can use for getting up and running with the cluster using any of the cloud environment that you have got. The same way you can also set up and run your own Postgres database by using this particular playlist. See, why I am actually creating these playlists is that if you want to create an environment where you want to play with multiple services, you can actually do it. So if you follow each and every playlist, and if you can create your own little database, little big data cluster, and work with the ETL, then you can actually chain them together. It's very simple, right? But you need to understand each and everything. That's very important. I think the Kaggle environment is up and running. So yeah, Kaggle environment is done. I am going to start the Spark session. I am not going to go into detail about each and every step. Okay, I will be just giving you the overview of what is going on. I would request you that this is actually a fairly simple activity that we are trying to do. Okay, so don't worry about that. If you miss certain things, once you practice, you will understand it. Initially don't feel frustrated that okay, this is going really fast. Don't worry about that. Practice it, you will get it. So it's very simple technology. I have started the Spark session, and the data set is already along with the notebook. Okay, see, the customer data set is along with the notebook, and this is a very simple data set. The reason why I have taken the simple data set is that once you understand how to do with simple data sets that is out there in the wild, then working with massive data set will not be a challenge. So that is the concept I am following. I am just reading this using the path here, and I am saying header equal to true and infer schema equal to true, so that I can actually get the schema from the CSV itself. So I am going to execute this. Schema is kind of a data signature of the CSV of the data inside the CSV file. It's kind of a signature. So these are the steps that this particular notebook will take. I already explained in the presentation, right? We need these things. I have written the same thing here. I am checking the head of the, so these are all basic checking steps that we do. This is constantly we do a lot of checking. I'm going to zoom in a bit so that this is not good. So let me go back, and you see the columns here. It's fairly around some 8 columns, not that big, but you see there is a column gap. We are going to fix it. So what we are going to do is we are going to get the schema, and we are going to build a new schema. So we can actually use this pyspark.sql.types, and we can build a new schema. Just follow this syntax. You have to use struct type. Struct type is the schema declaration class, and from there you can use struct field and integer type, string type, date type. There are lots of types there. You can use that and you can create the schema. And next what you are going to do is, see, in case of pandas, if you are from the pandas background, what you will basically do is, you will take the customer underscore raw.columns and we will just put an equal to, we will take this list, copy it here and correct it. Okay, but in case of Pyspark you cannot do that. So we have to go through the process. So what we are going to do is, we will get the schema. We have got it from this particular data. We will get the schema, we are going to change it. So I got the schema here. You see that I have a gap here. Work experiences, there is a gap. Spending score, there is a gap. But then I copy it here and just I change that. I remove the gaps, I remove the dollar symbol, etc. I'm not doing any great stuff here. I'm just copying this that I got it from the actual CSV file, and then I'm creating a schema. Then I am importing the complete data set with the updated schema. This is a very usual way of working with the data sets inside the big data ecosystem. So yeah, this is a small data set, we are doing it, but in big data set what will happen is the data will be actually partitioned. So we will only take the first partition and we will do this activity of understanding the schema, and then using that schema we will pull in the entire data set. So keep this in mind, this is a very important strategy. Okay, now once we have done that, you will see that there will be an error getting raised. So I am using new schema and it will say that, okay, I am unable to find annual underscore income, I am unable to find work underscore experience, all these things. Don't worry about that, it will anyway get created. Okay, so this is one of the most important strategies that you will learn. And once you do that, you see the new schema is as we want. We don't have any breaks here. And now once you have the table, what we are going to do is, we are going to start creating the database. So we are going to first show the database is available. By default there will be one database called as default. We are going to create a database called as customer underscore spark underscore db, and it will throw some warnings, don't worry about that. And then we are going to use that table, and then we are going to write the updated customer table, this table, as this data frame as a table, save as table, and we are going to use override method, and we are going to use Parquet file format, and we are going to write it. Okay, one more important point, I think I did not execute the, I think I have not executed the code. Just a minute. Yeah, I have not executed the code. Yeah, let me execute the code again so that I can actually, because I was talking with you guys, I forgot to execute the code. Just a minute, let me execute it. Yeah, till here we have it. I'm going to execute this also. Yeah, I've done that. I'm going to execute the show database, and I'm going to execute. So there is no Hive file system here, or Hadoop file system here, so I'm getting these kinds of error. Don't worry about that. This is even in the Pyspark cluster environment also you will get the same kind of warnings. So these are all regular warnings. I'm going to create the database. So the database will get created, and then I'm going to create the, I'm asking them to use this asking the execution environment, the Spark session, to use the customer underscore spark underscore database. And next I'll be saving it. So this is as simple as it can get. So this particular data will actually get stored inside this area, inside the Spark warehouse. So in a moment you will see that there is a warehouse that is getting created, and inside the warehouse you will see, you saw that, and inside the warehouse you will see that there is a database that is getting created. It will get populated in a moment. It takes some time in Kaggle. Then you will see that inside the Kaggle environment we will have the table. So you saw the database come here, it's actually a folder, and inside the database folder you will actually see customer spark underscore table, which is again a folder, and if you go inside that you will find the Parquet file. So this is something that you need to see, and Kaggle is a very good environment for you to see this. You see that it is coming from the top right, and you see the Parquet file here. This is what I was trying to say, and you see the size. So this is just 26.09 KB, and what is the size? This is 74.35 KB. It's almost 1/3 of the size of the actual CSV file. So Parquet has a very strong compression mechanism called as snappy. You'll be learning those things. I'm just giving you additional tidbits of information. As we see that, okay, the table has been created, you can check the table, and when you are going to use this notebook, it will be a separate environment. So don't think that, okay, I have created a table, will you be able to create it? So don't worry about that. You will have a separate environment altogether. Then you will have select star from I'm just doing a select and checking. So this is regular SQL that you are using. Select star from the table, limit 5. So I am limiting it. You need to use show. Spark does lazy evaluation. So if you give this command only, what will happen is it will actually execute the command, but it will not actually complete the execution. It will complete the execution and show it only when you use this show command. Keep this in mind. Next, this is what we wanted to do. Once you create the new table, so we have actually, as I was explaining, we have already covered most of the things that we want. So if you see, we have already we have completed this first step already. We have completed the second step by creating this Spark table. Now we are going to work on the third step right now. If you go back to the Spark environment, right now we are trying to work on the filtering. So I'm using the where clause to filter where annual income is greater than 15,000 and spending score is greater than 50, and I'm going to count how many are there. So there are total 2,000 rows, and out of that 972 rows have a higher income of 50,000 and spending score greater than 50. This is what you find. And next, what we are going to do is we are going to use create table so there is a method to use create table as select. So CTAS format we can use, and then we can use the same query and update the new table. So if I execute this, what will happen is I will get the new table, transform customer table, and then you can select from the transform custom table also. And if I use, so for an example, if I say spark.sql show tables, and ensure that you give a show here, you'll see that there are two tables right now. So one is the transformed customer table and another is the customer Spark table that we started with. We can actually show it in multiple ways. I'm just showing it to you. Finally, we want to write. So we want to write, I shouldn't be using a limit here, so I'm going to remove this. I hope that in the final one I'm not using a limit. If you limit it, then there is no point of transforming it. Most of the data will be lost. So I'm going to execute this, and you will see that it executes in no time. It's a very small data set, and you will have a new file in the right in the kaggle working.transform. So in a moment you see that transform.csv has come into picture. Okay, so the entire transformation activity was done. It looked very simple, but try it out by yourself step by step. You will know the activity that is involved. When you look at the video, you don't actually see the research that is gone into that video. So once you sit with the actual raw data set and try to do it without actually looking at the video, then you will understand what is going on. So try to do that and see what you learn, and you can share it with me also. That will be much more interesting. So we have executed this filter, we have created a new table, we created the CSV file also, and then these are the 5 steps that we did in Kaggle notebook. Now the final step, we have to actually convert the important steps of this entire Kaggle notebook into script. This is where you should understand about the how to write the Python script. So let us go to the terminal. The Python script is already written. Okay, the Python script is already written, and let me do a connection with the cluster. I have connected with the cluster right now. I am going to start the server inside the cluster functions inside. So in the meantime, so this is the cluster environment, and this is my local environment. I am going to go into Git folder where I maintain all my folders related to my project. and I'm going to check this EMR instance practice. This particular Git folder will be shared with you guys. The code will be inside that. You don't need to worry about that. I'm going to show you how the code is actually written inside. I'll be using Vim. I'm thinking that I'll just use a cat command. I'm not going to show you because I'm not going to edit anything. The server is up and running here. I'm going to just use cat command, and I'm going to show you how the code is. So you'll see that whatever we did in Kaggle notebook, we are actually going to do the same thing here, but we are going to lose couple of unwanted, I wouldn't say unwanted, we are not going to do the show commands of the tables inside the Python script, because you don't need to. You have already tested it out in the Kaggle environment. Inside the Python script, you are only going to work on extraction. So this is the file path where you start the extraction process, and then you will continue the you will start continuing the creation of the schema. Just a minute, guys. So we have only executed the various steps that is required for our activity. First is to read the file. So I created the Spark session. You need to create the Spark session. Okay. We are actually not running the Pyspark environment here. We are going to run inside the Spark submit. So we'll see that in a moment how it is being done. And we are going to, once we create the Spark session, we already have the schema. So we are not going to do the schema checking again inside the script. So we already have the schema. So we are going to copy paste it inside the script. Okay, so we did this exploration inside the Jupyter notebook. So we are not going to redo it. We are not actually going to automate it. We are going to read the file, but we are going to use the schema. And then what we are going to do is I am going to give some kind of print statement out whenever the activity is going on. And I am going to use this schema also to check as the particular script is running. We have to see what is going on, right? So it will run pretty fairly fast, but we can see the logs coming out. And then I am going to create the database here. So I am going to create the database. I am going to use the database, and then I am going to create the table. Finally, keep one thing in mind. I had to again repeat it. This particular file has to be inside the Hadoop file system. It cannot be outside in the local file system. It will not work. It has to be inside the Hadoop file system. Then only this entire script will actually read the this particular CSV file, or else it will not. So keep that in mind. And then this particular schema, we are going to create these tables. Everything will happen inside the Hadoop file system if you provide the Spark warehouse directory path. So I will show you how to do that. If you don't do that, then it will come to local file system. So it is how to you have to follow the configurations very closely in case of big data Spark execution, big data transformation, ETL transformation. After I create the database, I am creating the table. The same process, whatever I did in Kaggle, I am going to use the same method, and then I am going to use the transformation. Transformation is basically I am going to filter it, and once I filter it, I am going to create a table. And once I filter once I have created the table, then I will select all the things from that table and then write a CSV file. That will be actually written again to the local environment. To the Hadoop file system only. This particular CSV file also will be written to the Hadoop file system only. And if you give this tilde command, so this is a mistake I made, but I still want to keep that mistake. So initially I was thinking, okay, I am going to give this tilde command and this will write to the local file system, local home file system in Linux. However, it did not work that way. So once it executed, what happened is it wrote the file directly to the Hadoop file system, and it created the folder. This tilde, it created a folder called tilde, and it wrote the file inside that. And then finally we see that the write is complete, and we say Spark is stop. Also remember one thing. We start with this checking, where if the name, the file name is equal to the main file name is equal to the main, then this entire code gets executed. So if you are going to create a function, so you have to put everything inside the main function and you have to execute it, because this is executing like a Python script. Here we are not having any functions, we are going to run it as a script. So I am just using if name equal to main and the entire process starts. If you are not going to use this, if you are going to use functions, if you are going to call the file, if you are going to do other activities, Python related input activities and output activities, then you need to write the program in a different way. At this moment, this is the most simplest way of attacking the ETL activity for the first time. Okay, so it's a fairly simple process that we have followed. And now what we are going to do is, this particular you can actually pull this entire repo, the repo that is already there. I have already pulled it here, pulled it into the cluster environment, and from the cluster environment I can start executing. So if you see, so now that I have explained everything, let me actually reduce the host area and let us concentrate on the. So this is the EMR instance practice that I already pulled from the GitHub repo. Let me show you the GitHub repo also, just a minute. This is the repo that I am talking about, and you will find the pipelines inside the pipeline script. Building pipeline is different from pipeline scripts. So this is a script that we are working on right now. So you can see that here also. You can take a look at that directly also. So let me go back to the terminal. Let us start working on the important aspect. So let me go back to the presentation before we go to the terminal. As I told you, we are not going to run the Pyspark application here. We are going to run Spark Submit. So before we run Spark Submit, we have to create a master. When we are going to run Pyspark, right, we actually we don't need to create a separate master. We say that master will be yarn, and internally Pyspark actually calls the yarn negotiator, and the internal activity works. But when you are going to do a Spark Submit, we have to manually start the master. So let us see how to do that right now in the terminal. We have to do the master. We have to start the master. We will get the master IP like this, and then we have to use that master IP to start the worker. So you have to use this class. Okay, this class org.apache.spark.deploy.worker. So this particular class has to be used, and we have to start the worker there. And then after the worker has successfully started and attached with the master, you can then use that master to execute your query or execute your application. So master will not work, only the worker will work. But there should be a master, because there can be multiple workers also. And you can also you cannot actually manage how the workers are getting assigned. You can only manage the applications, how you are going to deploy it. The actual worker assignment and worker management is done by the master. So you cannot touch that, but you can work on deploying your jobs to the master. Now let us start the master, start master.sh. Let us go to the terminal. In the terminal, I am already, okay. So let me show you that I have already pulled the, scripts. I am going to do a cat here. So I am inside the terminal, inside the cluster right now. Okay. So this is my host and this is my cluster. So if I do the pipeline execution, so if I say customer.csv, you will see that the entire file is already here. So I have already pulled it to cluster also. So this is much more easier way. Using GitHub is way more easier to control and share stuff with others. So if you are new to GitHub, do learn GitHub first. If you are learning coding is also learning programming is secondary. Learn GitHub first, because you have to store your code and you have to share it with others. It's very, very crucial, guys. So let us start the master. So in case of the cluster that I have created, let me actually share you the location where you can find the main executables. So it is under opt Spark 3, and you have to go under bin. So under bin we have Spark master. So we will see that under bin we have Spark submit and we have Spark class. We have both of this, and in order to find the Spark master, you have to actually go to sbin. So sbin is basically scripts binaries or shell binaries. Okay, so here you see that we have various binaries here. It is full of shell binaries here. So here you see stop and start master. So where it is, yeah, here. So you can come here and start the master also, or you can actually use absolute path and you can give it and start it also. So all you need to do is just start it. It will get started. Once you start this master, right, I will show you something in a moment. Just hold on. Once you start the master, you come back to your instances and get the instances DNS number, DNS IP address, or this particular IPv4 public DNS address. Take this and come to the, yeah, just a minute, sorry, I missed the browser area. So what I was showing is that come to your instances inside your cloud environment, get your public IPv4 DNS, copy that, and then come to the address bar and paste it. Since we already gave the 8080 port open, now you will be able to see the Spark master running. So in this place you can actually see the Spark master running. So this is the Spark master IP address or the connection string that you need to copy and keep it, because we are going to use it next. Okay, so this is where you can actually see how is the code running. So we can see that in a moment. Let us go back to the terminal now. And the next code that we are going to execute is that we want to work on the class. So let us go to the PDF and I will show you. So we have to work on this. So we have to go to Spark bin, Spark class, and we have to use this, where it is. We have to use this series of classes or Java classes, and then we have to give the Spark master IP address here. Like this we have to give. So let me start that process right now in the terminal. So I am going to go back one step and I am going to enter into, you will see that once I create this, right, this particular session, this particular location will get held by the worker itself. So I will have to create one more session to the cluster. So let me show you how to do that. It's fairly simple. cd bin. Once you do the bin, you have to say start, and you will see that there is already class available there. Oh, sorry, I have to use just a minute. I think I'm missing something. Oh, I am using the wrong word. So I should say Spark class, not start class. Spark class. And I have to use this command. So I have to use org.apache.spark.deploy.worker.worker, and all are in small case. So the point, let me go back to the terminal. The point is that in the presentation I actually make it bigger, but in reality it is all small. You see that the deploy.worker.worker, this worker is having a capital W. So keep that in mind when you're using the command. This worker has capital W, and then I have to provide the IP address of the master. Then once I give this particular IP, the connection string, what will happen is the class will get generated, and once that worker gets assigned, so it is saying successfully registered with the master. If you go back to the browser and if you refresh this page, you will see that the worker gets assigned here. So you will see the worker ID coming here. This is how you actually assign the worker. Only after the worker is assigned, then you can do the Spark submit. Before that, you cannot do the Spark submit. Keep that in mind. Let us go back to the terminal. And as I told you, this particular session is locked right now. So you need to have one more session, right? So I will be using this location to start working on another additional session. So I will be using the same, I have the SSH key with me, right? So I will use that key and I will connect with the cluster again. So I can have as many connections I want, but I am using the terminal muxer so you can see it in parallel here. Now what I am going to do is I am going to go into, okay, before I actually go into the, go and show you how the script is executed. It's a very simple thing, but I wanted to show you that what are the what are the databases available, because after I execute the script, I will show you that there are databases. Now you might be wondering, okay, Kamal, what if the databases are already there and you did not actually execute the script correctly? So this could be a very valid reason. So I am going to show you how this, how the databases are already available inside the Spark SQL environment. And then you can, I will be running the script and I will be submitting the script and I will show you how it is getting done. At the end of the day, the point is that you also need to do this checking, okay, so that if you are facing any kind of problems, then you can debug it very easily. So sometimes we miss this basic step and our script errors out. So I do a show databases and you will see that what are the databases available. So you will see BYOB database, you will have Spark DB and you will have default. There is no anything related to customer. Okay, that's what I wanted to show you guys. I'm going to exit out of it. Next, what I'm going to do is I'm going to go into EMR, the instance, and I'm going to go into the pipeline scripts and I'm going to do a Spark submit. So the script that I'm going to use is I'm going to call Spark submit and I'm going to use this master I need to change. So I need to change the master. Okay, I need to use the correct IP address master or else it will fail. And before I actually give the script, I am going to give the configuration, and inside the configuration I am going to say Spark SQL dot warehouse dot dir is equal to, I say the warehouse directory is inside user Ubuntu warehouse. This warehouse is actually inside the Hadoop file system. Okay. So this is inside the Hadoop file system, and now once I execute it, I am actually inside the pipeline script, so I don't need all this additional locations here. I can just remove this. I can directly run the command. So if I run this command right now, it will start executing. So let me actually make this little smaller. Okay, so there will be some additional things happening here also. Let me execute this. So you'll see that it will take a second and it will start working out the activity. You see that the worker URL is started here and the actual registration, and you see the output coming. Let it complete. I will show you the entire output, and all the output, all the printing has been completed. The activity has been also done. And if we go back to the browser, you see nothing has changed, but actually you have to refresh it. Once you refresh it, you will find that this additional application has been done and almost 2 cores have been used and this much memory has been executed at this time in Ubuntu. So you see all these things done. It took only 15 seconds, and if you can click on the app ID, you will actually see what kind of activity, which worker, and why it got killed, etc. So this was a standard out, standard error, so there is no any issue. We can get all the information like this, right? But what we want is whether our files have been created, whether our database has been created. So let us go back to the our cluster, and inside the cluster what I'm going to do is I'm going to create again the Spark SQL, the instance, Spark SQL instance, and I'm going to check whether the database is created. So we wanted to create a customer database, right? So let us check whether the database has got created. If the database is created, next thing we need to check is whether the file that we wanted, that we saw inside the Hadoop cluster, inside the Kaggle environment, whether that is created. So those 2 things we have to check. All this checking you will automate it in your scripts when you are running the ETL. However, here we are actually understanding these things, so I am showing it to you step by step, and you will see that here the database is not created. So what has gone wrong? The major point is that the idea of giving the Spark submit with the warehouse location is that it actually creates the database here, but the database is not created here. Then what has happened? So let us actually check it out. Exit. Once you exit out, and if you exit out and go to the home, inside the home directory, usually what happens is there should not be any Spark warehouse here. If there is a Spark warehouse here, that means that the command that we executed in the Spark submit was wrong. Okay, so let me show you what was the mistake that I would have committed. Just a minute, and I am actually going back with the history so that we can actually let me do a HDFS, DFS, LS. Before doing that, let me actually do an LS on the Spark warehouse. So let us do an LS on the Spark warehouse, and you'll see that customer_spark_db has been created in the local file system. Okay, but we did not want that. We want this particular database inside the Hadoop warehouse. And if you do an LS of the customer DB, like how we did in the Kaggle environment, right, you will actually find the actual database inside that. So the table that we created on the Parquet file, it is created in the local environment. What I told you was that it should be inside the Hadoop environment. So let us actually go and see inside the Hadoop environment what is the case. HDFS DFS -ls, and if I do a home, not home actually, let us do an user and let us do Ubuntu. This is the location where we are actually looking for the warehouse. And you know the mistake, what had happened was, when I actually gave the command, I had given Spark warehouse, but the actual folder is just warehouse. Okay, and if I look at inside this tilde folder, if I do an ls, you will see that there is the file transformer.csv. I told you, right, it will create the folder tilde, so it has created the folder and it has put it inside there. So the point is, guys, that we have already come to the conclusion that we have completed the entire process. So let us go to the PDF. We have seen the ETL activity, the first ETL that we have already done. We have done the design inside the Jupyter environment, and we then created the Jupyter notebook into script, and then we understood how to initiate the Spark job using the master and worker, and then we executed our script. So this is an end-to-end activity that we have done. You can do a lot of things after you have mastered this step. So most important thing is, guys, try to practice as much as possible. Try to work with various data sets. Don't complicate it. Just do basic schema understanding, schema correction or the column name correction, doing some filtering, doing some group by, doing basic aggregation. All those things you can try, and create new tables, and then write it out, see how is the database getting created, where is the database getting created, whether it is in Hadoop file system or it is in the local file system, what kind of files are coming out of the once you create the tables and once you create the database. Let me go back to the terminal once, since I was talking about that. If you actually take a look at this customer Spark table, right, you will see that it is a Parquet file. You can actually make this into a CSV file, you can make it into a text file, you can make it into gzip file also. You can do various kinds of format in this particular file when you are actually writing it. So keep that in mind. And also you can write the data directly to the databases also. You can connect the Spark session to databases. So we'll be looking into these things in the future. So going back to the presentation, so keep practicing, guys, and I hope that you like this content, and do leave a like and subscribe to my channel so that further updates, whichever video is getting uploaded, you will immediately get your update, get the update in the your YouTube dashboard directly. So with this, I would like to conclude this video, and as usual, 4 words: practice, 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 practice. See you guys. Have a great time.